today is Module 1, Lesson 29. We're going to continue working on solving percent problems, analyzing them. How many of you from ELA have heard the word claim? Well, in today's lesson, we're going to see two claims, and it's going to be our job to prove or disprove those claims. All right, so that's our goal for today. And as you can see, today is the very last lesson in Module 1. So tonight, tomorrow night, when you're studying, you can take your module papers, your exit tickets, your vocabulary out, and bring back your empty binder on Monday for your Module 2 materials. All right, so let's take a look at the first claim. Please highlight the first claim in your notes after you put the date on the top of the page. The claim is to find 10% of a number, all you need to do is move the decimal to the left once. So if you think that claim is true, on the line write true. Highlight the claim on the top of the page. It is in italics. You can share highlighters with your table if you have to. You're welcome. All right, so how many of you think that's true? Raise your hands. You got nothing to lose. How many of you think it's false? All right, let's see what happens. So let's find 10% of 300. So of 300 means 300 is my whole. 10% out of 100. Well, 10 out of 100 is 10%. So what is x? If I do times 3 times 3, x equals 30. Let's do it the other way. They said that I could just move the decimal one place to the left. If I move that decimal one place to the left, what do I get? 30. Does that work? Yes. So this time it was true. Let's see if it works every time, or maybe that was just a coinky-dink. I knew that was coming. All right, so let's try C. So how much of 80 is equal to 10%? So what is x? Can I do that? No. So what do I have to do? I have to scale it down. Then I can scale it up. And what is x? Times 8 times 8. X equals 8. Let's see if it works by moving the decimal one place to the left. What do I get when I move the decimal one place to the left? 8. So again, it's true. Should we try one more? Let's try one more. We're not going to do all of them, so I want to make sure we get to the second claim. So how much of 64 is equal to 10%? Can I scale from 100 to 64? So I'll scale it down. X over 64, 1/10. How am I going to get from 10 to 64? Oh, yes, I am. Oh, yes, I am. Because I don't discriminate against the... Right. I don't discriminate against the big fat zit in math. Okay? So 10 times what? Now, if I can't figure out what the multiplication is, what's the opposite of multiplication? Division. So can't I go to my margin and see 64 divided by 10 is 6.4. So that means 10 times 6.4. 1 times 6.4 is 6.4. Let's see if the decimal method works. We had 64. If I move the decimal one place to the left, what do I get? So is it true again? It's true. So you can go back to the top of the page where you highlighted your claim and write down that our claim is true. Our claim is true. Actually, I should probably write it over here, not on the prediction line, because it's okay if your prediction is wrong. It's a prediction. Any questions on that? So here on this table are the answers if we had solved all of them, but we did just solve these three. So 10% of 300 is 30. Did we move the decimal to the left once to get our answer? Did we move the decimal to the left once to get our answer? Yep. 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 So this is proving our claim. It is sort of a shortcut. If we had continued solving the other problems, these were all the answers. So this proves that our claim is true. To find 10% of the number, just move the decimal to the left one. I use this trick a lot when I go out to dinner. We don't go out to dinner a lot. I like to cook. It's cheaper. I can stay home in my pajamas and cook. Can't go out to dinner in my pajamas. But we always, you have to tip your waiter or your waitress. And they say it's customary to tip 20%. So I always look at the bill, and I can figure out 10% by moving the decimal over to the left. So if it was $60 for dinner, okay? So if it was, here's my ticket, okay, all the stuff we ate, $60, she puts a little smiley and a thank you at the end of her bill. All right. So what's 10% of 60? I move the decimal to the left once. What's 10% of 60? $6. But I'm not going to tip my waitress $6. That's only 10%. I'm supposed to tip her 20%. So what could I do to my $6 that's 10%? I could just, I'll just double it. Instead of doing 20% over 100, I could figure out 10% by moving the decimal and then double it. And then if she was a really good waitress, I'll throw in a couple extra dollars. Okay? Let's continue. So let's take the claim, look at the next claim on the bottom of 128. Okay, so highlight the claim. If an item is already on sale, and then there is another discount taken off the new price, this is the same as saving the sum of the two discounts from the original price. What that means is, how many of you shop at Kohl's? Yeah. So Kohl's always is having a sale. Oh, it's Wednesday sale. Oh, the sun came out sale. It's the last Tuesday of the month sale. The day ends in Y sale. There's always a sale. But what do we also get in the mail? Coupons. Exactly. It's a joke because Kohl's is always having sales. So, 3, 2, 1. Let's regroup, please. However, so if you go into the store and the item is already 20% off, then you walk in with a coupon that's 10% off. You get a nice deal. But sometimes there's an item on clearance that's 30% off. And because it's on the clearance rack, they don't let you use the coupons. Sometimes the coupons, they no good. Or we'll get the coupons, and guess what? The coupon expires the day before the bigger sale. All right, so what should I do? Should I buy it at 20% off and then use my 10% coupon? Or should I buy it when it's 30% off? So the claim is asking you, are these the same discounts? Will the shirt be the same price? So let's do a little prediction. How many of you think that 30% off would be the better deal? How many of you think 20 and then 10 would be the better deal? How many of you think it's the same thing? All right. So let's prove if you are correct or disprove. All right. So let's take a look. So Sam purchased 3 games for $140 after the discount of 30%. So let's be careful when we're setting this up because we want to know the original price. We want to know what 100% was. But now we have to be careful. You could draw this, write this on your notes. Let's be careful. God bless you. My first reaction, and who else wants to do this? Don't. But God bless you.
Thank you.
30% off, so we paid $140. Is that correct? Why not? Think about what we did yesterday. 140 is what I paid. $140 represents what I paid.
Over 30 would be 60.
Right. My 140 represents when the 30% came off. That 140 represents the 70% that I paid. Remember that what you pay is the percent that you pay. This was 30% off. So now I can fill in the rest of my table. Or my double number line. So what are my intervals here? I took 7 boxes to get up to 140. Draw this, please. So what's 140 divided by 7? 20. So my interval, I was with you. I knew what you meant. So what was the total price of the item? The original price was $200. The sale of 30% off, he paid $140. If you wanted to use your fraction method, I can move all this down. How many people want to use the fraction method? This guy? Well, we have to be careful again, because 140 was part of the total cost. But I can't put my 30% there in my fraction, because 140 does not equal the 30% that they took off, does it?
Why do we put it on the top instead of the bottom?
Because $140 was the price after the discount. We don't know the original price. So 140 was the part of the total price that I paid. But 140 does not equal the 30% that they took off. What does 140 represent? The part that I paid. So what percent did I pay? I paid 70%. So that was from yesterday's lesson. You have to think about, is that the part coming off? Or is that the part that I'm paying?
When I was doing this, the sheets yesterday, they had something like this. It was like except there wasn't
Right.
another, it was like
Right. Well, that's why I want to teach it to you for that. Yeah, that's why we're going to do that today. So times 2 times 2. So x equals $200. But remember, $200 was the original price. The sale price at 30% off was $140. So that was method 1 when it was 30% off. 30% off is a nice deal. Let's see if it would have been better to use the 2 coupons. So the first coupon was 20% off. So what part of the $200 item is equal to 20% off? Write this down, label it first discount, second discount. Everything I write on the board, you should be writing in your notes. Twinsies. So now, times 2, times 2. So the first discount, they're taking off $40. So I'm going to come over here to the right. If $200 was the original price, the first discount, they took off $20, up $40. So the sale price after the first coupon's $160. Okay, now the second discount comes off of the $160. So now the price of the item is $160 that they take the next 10% off. How can we figure out 10% off of 160? Yeah, let's just do the decimal to the left one. So the second discount is $16 off. And it's $16 off the $160 because that's the new price. So the sale price is $144. So now let's compare them. When it was 30% off, we paid $144. When it was 20% off plus 10% off, it was $144.
How'd you get 144?
Because after I took off the first discount, the price was $160. Then I took off the 10% coupon, which was $16 off. So 160 minus 16 is 144. So which is the better deal? Should I use my 30% off coupon, or should I use my 20 and then the 10? If you think I should use the 30% coupon, raise your hand. If you think I should use the 20 and the 10, raise your hand. Some of you didn't vote. Who's not sure? Okay, thank you for being honest. So let's take a look. Oh. Okay, so let's take a look. This time I'm paying $140. This time I'm paying $144. Which one am I paying less money? Which one is cheaper? Is $140 cheaper? Or is $144 cheaper? Which would you rather pay? Yeah, I'd rather pay $140. Because then with those extra $4, I could buy a bottle of water and a Twix bar at the checkout on the way out. Okay? So this, boys and girls, that's cheaper, Alex. That's less money. I want to spend less money so I can get my water at my Twix. So the 30% is the better deal because I'm spending less money. Does that help a little bit? Feel better, stronger with it?
Why would it be less if they're both 30% off?
Because they're not. Because this is 20% off. So now I have a cheaper price. The 10%, the second discount, is coming off $160.
So you can't add the percents together.
Right, we're not adding the percents together. Because the second discount always comes off of the new price. Next time you go shopping with your parents, if you have a coupon watch, they take off all the sale prices, they come up with your total, then they use your coupon. They don't use the coupon and add it to the other sales. It's separate. All the stores want to make money too. Okay. So in summary, the price with the 30% discount was $140. The price with the 2 discounts was $144. So now, do we agree with that claim? No, because they said it's the same. So the claim was false. So on your homework, I would like to see it set up just like this. Original, first, sale, second. Remember that your homework should always match the class notes that we took in class. Okay? In summary, one more time, let's take a look at this last example to prove it one more time. If it was a $100 item, what's 20% off? $20. So the sale price is $80. I don't understand why you're packing up. We're not done. You should be writing this in your notes. Okay, so this is with 20% off. It's $80. Now let's do 2 10% discounts. So what's 10% of 100? $10. So after the first discount, it's $9. What's 10% of $9? What's 10% of $90? 9. So 90 minus 9 is 81. So is it the same? No. So when you're combining the discounts, it's not the same as when you're using the 1 discount. Okay, so this, boys and girls, is the end of Module 1. Well done. Lots of hard work.